Right, short date please, and learn objective, press pause. Pause it while you're doing that please, and then play when you've done it. Right, okay, so you're using similarity to solve problems. A lot of we'll be combining a few of the different methods that we've learned in order to answer these. So for example, if we look at this here, we've got our parallel lines, and we've done some work on finding the different angles on the same angles on parallel lines. So here, can we prove that these two triangles are similar to each other? Now, in order for them to be similar to each other, all the angles need to be the same, don't they, with the triangle? All the angles are the same. So let's have a little look. So if we call this angle A here, angle A, can we from this work out whether we have the same angle on this triangle here? So we've got a triangle here at the top, triangle there, and now we've got a triangle down the bottom. So we've split this in this shape into, we're just focusing on the two triangles. So we can see here that this angle A, if we go back and do our alternate angles, isn't it, where we go here, down and across there, we know that this angle here is also A. Okay, the same here then when you have angle B. Okay, angle B here. Okay, so this angle here, angle B, again you got the Z here, so we know that this is also angle B. Okay, and then again alternate angle, and then we've got this angle here, and we know that vertically opposite angles are also the same, so these two angles will be the same as well. So we can see these are similar triangles because all the angles are the same. Now the lengths of the sides are different. So say for example this side was if this side was 4 centimeters and this side was 2 centimeters, we can see the ratio there, can't we? So we've got the larger one is 4 to 2, and so on. And from there, if this happened to be 5 there, we could work out that this one here is going to be 2.5, etc. Okay, because we can see the ratio there is timesing by 2, or in this case dividing by 2. Okay, so that's 5, that would be 2.5, and so on. So we can, just with across these parallel lines, work out that they are similar triangles, and then we can work out angles, and we can work out sides and things like that. And really a lot of the work today is you just working those sort of things out for yourselves. Okay, right, let's look at and we're going to do one question like this today, unless you do the extension, do a couple more. Right, so a little look. So we've got this here, so we've got this shape there. Hopefully you can see that reasonably clearly. Okay, so what we've got what, and this is how we need to kind of think of these, I think, is to think of them as think of it as two triangles. Okay, so we've got our triangle here. Okay, we've got a small triangle at the top there, and then we've got overall we've got a bigger triangle. So we've got a small triangle and a bigger triangle. So say for example it's asking you to calculate TR, so from here to here. But one way of just doing these, just when you get just to start off, is actually just to draw. I'm going to draw this small triangle first. So here's the small triangle, and I can see that's 3 centimeters, that's 6 centimeters, that's 4.5 centimeters. So now I'm going to draw the big triangle, the whole thing, basically the whole thing. Okay, so then that's 3 and 3, so this is going to be 6 centimeters, this 6 and another 6. Okay, it's going to be 12, and then from here, so from here we can work out what PR is as well. Okay, what PR is as well, because we can see that if this is 4.5, each time each side is the ratio is doubling, isn't it? So this would be 9 centimeters. Okay, so it's asking what is T to R. If that's 6, we know the whole thing is 12, so TR here would be 6. Okay, and we've sort of achieved that mainly by so we can sort of see that to spot it, but when you draw it separately into your small triangle and your large triangle, you know, especially for some of the trickier ones, that might make a little bit more sense for you. Okay, oops. Move that up like that again. Right, let's have a look at another one. Let's have a little look at another one. Right, so we've got this one here. Okay, this one. Okay. And again, we've got a smaller triangle at the top, and then the whole thing here. And these lines are parallel, and those lines being parallel really is makes the difference, isn't it? So let's have a look at the top one. What do we know about the top one? I'm going to just draw that in for the time being. The smaller triangle. Okay, I think I'll label it as well. So we've got the triangle BDE. So that's 4 centimeters. We know that. Okay, and then on the whole thing, we're going from B all the way to C, okay, and then all the way down to A, okay, all the way down to A, okay. Right, and we can see all the way down here, so we know that the 6, so this is going to be 6. So just from this first one, yeah, just from this, and we've got here, we know this is 7.5. So we can see from the 6 to the 4, we've got our small triangle to our big triangle. Okay, we can see that the ratio is going from 4 to 6. So we're timesing by 1.5, aren't we? Timesing by 1.5. So what is DC? What is this line DC? Now we know AC is 7.5, okay? So this is in the ratio of the bigger triangle, 7.5. Okay, so we need to get down to here. If we're timesing by 1.5 in this direction, when we go in the other direction, we divide by 1.5. Okay, so yeah, this 7.5 divided by 1.5, which is 5. Okay, so this would be 5 centimeters. So by splitting it into 2, we can do that. Okay, and again, if we, you know, if there's any other things we need to, any other sides we need to find out, again, we would use the similarities, now the ratio of the sizes. Now let's have a little look before we move on. Just a little look to see how do we know that these two triangles are the small triangle and the large triangle. How do we know that they are similar? Okay, well, let's have a little look. Okay, here we can tell that, again, we know at the top of the triangle this angle is the same, isn't it? This thing. So we look at the small triangle and the big triangle, we know that this angle here, we know that this angle here is the same. Okay, but then what we've also noticed, okay, is because these are parallel lines, these are corresponding angles, aren't they? So these two angles will be the same as each other, as will, okay, I'm not going to make any difference with the different colors here. These two angles will be the same. So you can see on our small triangle, both have B at their point. So yeah, the small triangle has B at their point, and then these on the bigger triangle, these two angles are corresponding, and then they all share angle B, don't they? So you can see that they are similar triangles. Okay, they are similar triangles. Right, okay. There's a really good worked example today. So please use that to help you. Okay, the worked example, and I think it'll only be number 6 will be the tricky one. Okay. So again, this is the work I want us to do today. So work page 210, questions 1 to 6, and then I've got the extension underneath. Okay, so work your way through that. If you have any problems with it, please ask. But again, a lot of this is then you sort of being independent and just having a go at it yourself. Okay, I know we can sort of work our way through these, and we're getting close to the end of the unit here as well. Okay, right. Okay, good luck with that. Bye.